Assalamualaikum warahmatullahi wabarakatuh, and hello. My name is Muhammad KHAIRUL AQIB bin BAHARUDIN, and I'm from J4EC 110-4H2. So today I'm going to show you guys my presentation about soil engineering laboratory mini project ECG 263. So the content of the project is the introduction is to introduce the substantial background information and details of soil mini project, thus to show the objective of the project have. The methodology is the type of method that being used and procedure that have been done to conduct the soil test at home. And the finding is what have been get from the test that have been conduct at our place, more specific at home. The discussion on the result that obtained from the test and why does it happen like that way. Precaution that need to be prioritized in every action during conducting tests. So the conclusion is to conclude the result that have been obtained, the suitability of the soil sample for any application, and the recommendation for every problem that being detected while tests have been held at home. So next is the introduction. So the first introduction is field identification of soil is limited to determine the water content, particle density, density testing, particle size and grading texture and permeability of the soil. Second one is it could be done without any major equipment or apparatus from lab or any machineries due to the project that have been done at student home. It is necessary to do general assessment of site during field reconnaissance and during the initial phase of work. Tests that will be conducted may suitable for ordinary or casual work, but in most cases it will be served as an aid. Field identification is one of the way to get the result early at the field. Result of field identification is only roughly of the result. The detail and the accurate identification requires a laboratory test. From the field test, we can determine the soil sample that we obtain if it is suitable for what condition or any application and what the possibilities can happen of the soil. So the conducted test was water content test. The second one, particle density test. The third one is particle size grading and texture. And the fourth one is density test. And the last is permeability test. So the water content test objective is to determine the water content of the soil sample, and the properties is water content, while the apparatus that needed is soil sample, glass container, weighing scale. That's all. So the procedure is take the weight of empty glass container and record it as mass 1 M1. Second procedure is place the wet soil sample into the glass container. Take the weight and of container with sample and record it as M2. Dry the soil under the sun about 5 hours and record it as M3. And lastly, calculate and get the moisture content of the soil. So firstly, we measure the weight of the container itself and label it as M1. The second step is we put the soil into the container and we weigh it again as M2. Next, we dry it under the sun for 5 hours. After 5 hours, we take back the container and we weigh it back and label it as M3. So this is the result of water content test, which is the moisture content is 30%. So the next test is particle density test. The objective is to determine the soil particle density, and the property is particle density, while the apparatus for this test is soil sample, plastic container with lid, and weighing scale. So the first procedure is take the weight of empty glass container and record it as W1. put the soil sample into the plastic container and weigh it as W2. Put the water into the container until half or 3/4 of the container. Close the lid and put the sample under the sunlight about 5 hours. Shake the sample to make sure the soil is mixed with water. Fill the container with water fully and close the lid. Weigh the soil sample and record it as W3 and clean the container and fill it with water until full and weigh it as W4. So this is the video of me doing the procedure. The first step is we weigh the scale of the container itself and record it as W1. The next part is we fill in the soil sample into the container and weigh it again as W2. So the next step is we fill the water into the container until it 3/4 of the container and we put it under the sun about 5 hours. After that, we shake well the container and the mixture inside the container, and then we fill in the water fully the container. After that, we weigh it again as W3, and then we clean the container and fill in with empty water and weigh it again as W4. So as we can see, the result of the particle density test will determine the particle density of the soil sample. That is 1.36 gram per centimeter cube. Next is particle size grading and texture test. The objective is to determine the soil particle size, grade and texture. The properties is size and texture, while the apparatus is soil sample, plastic jar, paper cone, water and ruler. The procedure is place the paper cone on top of the jar, put the soil sample into the jar through the paper cone, fill up the jar until half or 3/4 of the jar, measure the height of the soil, fill up the jar with water until full, hence close the lid. Shake the jar gently to make the soil mix well. Leave the soil for 5 hours, thus measure the height of the soil and water level. So we measure it after 5 hours and we determine the particle size, grading and texture. So as the result, we find it that the height of the soil is 3 cm, while the percentage of gravel is 53.3%, percentage of sand is 33.3%, and percentage of fine silt is 13.4%. Next is the field density test. The objective is to determine the soil sample density. The properties is density of soil, and the apparatus is soil sample, glass mold, weighing scale and ruler. The procedure is shape the soil sample with the mold at the soil surface and then weigh the soil from the mold and record it. Calculate the volume of the mold and calculate the moisture content of the soil and determine the dry density. And finally, we calculate the dry density. We weigh first the containers, weigh and record it, and then we fill it fully with the soil sample into the container, and then we weigh it again, and then we take the record, and then we need to measure the size of the container in order to find the volume of the soil sample. So this is the result, where the width of the soil sample is 3.5 and the length is 10 cm and height is 10 cm. So the volume is 350, while the soil weight is 340. The moisture content, we take the reading before, that is 30%, while the Buck-Cinti formula is mass of soil over volume of soil. So it is 0.971 gram per centimeter cube. So the dry density is 0.031 gram per centimeter cube. So the next test is the last test, permeability test. The objective of this test is to determine the permeability level of soil sample, and the properties is to Determine the permeability of soil sample, while the apparatus is soil sample, water, filter equipment, and stopwatch. The procedure is put the soil into the filter, pour the water into the filter, and then start the stopwatch. Wait until the water soak into the soil, let it dripping to the bottom of the filter. After the water stop dripping, stop the stopwatch and take the time taken and mark the height of the water. So, after we fill in the soil sample into the filter, we measure the soil sample diameter and the nozzle diameter and the height of soil sample. Next, we pour water into the filter and let the water soak into the soil sample. And then we mark the water level as the initial level. And then we start our stopwatch to take the time taken. After the water stop dripping, we mark the final level of the water and then we stop the stopwatch. So the result is we determine the diameter nozzle and the diameter soil sample and length soil sample, initial water level, final water level, and time taken. So we found out the K value is 3.85 times 10 power of negative 4 centimeter per second. So the discussion of the test is, the first test, the initial weight of the soil sample for the water content test is 130 gram. The water in the soil sample was evaporated and lost due to the exposure towards the sun for 5 hours. Thus, it resulting a final weight that is 100 gram. Hence, the moisture content of the soil sample is 30% according to the calculation. By deriving the second test, by deriving the data that has been recorded in the table from the obtained data, I able to determine and find out the soil sample weight, full water weight, and water height. Thus, the soil particle can be calculated and found as 1.36 gram per centimeter cube. The third test, we determine the size, grading, and texture of the soil sample were determined in this particle size and grading texture test by calculating the percentage of soil after letting it sit for 5 hours. After 5 hours await, the soil is graded into 3 parts, that is fine silt, sand, and gravel. Fine silt was mixed up until 13.4% of the total, while the percentage of sand in the soil was 10.3% and gravel percentage was 10.3% too. Based on the PSD table, it was being determined that the soil sample type is well graded sandy gravel. For the fourth test, the discussion is the mold volume has been determined in the field density test by measuring its size. The bulk density and dry density are calculated using the soil sample weight and its moisture content. The bulk and density data are 0.971 gram per centimeter cube and 0.031 gram per centimeter cube respectively. And the final test, for the permeability test, the water was stopped dripping at height of 2 cm of the bottle, while the time taken for the water to stop dripping was 8 minutes and 40 seconds. Based on the data that has been recorded, the permeability is 3.85 times 10 power of negative 4 centimeter per second. So the conclusion is, to sum up and conclude for this project, the goal is to make sure the students demonstrate the technique that have been learned and apply it on this mini project in order to solve soil engineering problem while also being aware of their limitation. Students are also allowed to choose the appropriate experiment for each fundamental concept that have been stated in the question. Thus, the outcome of the experiment is determined by the soil sample ingredient and its type. The outcome are also influenced by how the experiment was being done. To make sure the reading is accurate, precaution need to be taken. To get accurate reading of the moisture content percentage, the soil must be completely dry before taking the reading for water content test. Next, to reduce the error in particle density, the soil that has been mixed up with water should be no presence of air voids, and the mixture need to be shaken thoroughly before the reading is taken. Finally, to reduce the permeability test error, the student needs to ensure there is no volume change in soil during the test, and there is no compressible air present in the voids of the soil. So that's all from me. Thank you.